discussion on the height information textures. Previously, we discussed displacement texture. We will now cover the normal map. For practice, we will be using the file from the previous lesson. For now, let's unplug the displacement texture so we can focus only on the normal map. Alright? As mentioned in the previous video, unlike the displacement map, the normal map is a 3-channel image, so it makes use of the red, green, and blue channels. At this point, you may be wondering, why do we even need 3 channels just to define the height? Isn't 1 channel enough? Well, the problem with 1-channel data like bump textures is that they can only define flat surfaces. To give you a better understanding, let's look at this diagram. Imagine we have several pixels we want to give height information to. We can set a height value of 100 for pixel number 1, then 120 for pixel number 2, then 150 for pixel number 3, and so on. Notice how the surface created by these pixels is jagged or stepped. It cannot create smooth diagonal slopes. Yes, we can provide more pixels, like thousands or even millions of pixels, so that when they are combined, the surface looks like smooth slopes. It is like looking at a Minecraft world that has blocky mountains and valleys, but from a distance. This can be done for terrain or large objects. However, using high-resolution images for every bump effect is not a good idea, as they can consume a lot of VRAMs quite quickly. In general, this is not always the best approach. To solve this issue, instead of just using 1 channel, we can add 2 more channels to define the detail of the surface. This is the basic idea of a normal map. So how does this actually work? Well, the first element of the normal map, which I think is the most important one, is the 3rd channel, or the blue channel. Basically, this channel works like the classic bump or height map. This means that bright colors produce high elevation surfaces, and dark colors produce low elevation surfaces. In other words, how the surface is placed in the z-axis direction. Until this point, the normal map is exactly like the bump map. Okay? What makes normal map unique is the red and green channels. The red channel is used to define the surface tilting against the x-axis direction. High values mean that the surface is tilting towards the positive x-axis, while low values mean it is tilting more towards the negative x-axis. As for the green channel, this channel works exactly like the red one, but in the y-axis direction. So higher values mean facing towards the positive y-axis, and lower values mean facing towards the negative y-axis. So in short, a pixel can have height information controlled by the blue channel, and also tilting information controlled by the red and green channels. This is why normal maps can deliver more believable bump effects compared to classic 1-channel bump maps. With normal maps, a surface or an object can look way more sophisticated than its original geometry. Alright? In Blender, if we want to use a normal map, we need to use the image texture node. Please note that although normal map uses 3 channels, red, green, and blue, the way it uses color channels is not like the color texture. So you should use the non-color option in the color space parameter. Next, you need to plug the color output into a special node called normal map. And finally, send the normal output to the normal input slot in a principled BSDF node. Again, if you have the Node Wrangler add-on, all of this setup is done for you automatically. Okay? Now, if you already have something like this, you can control the bumpiness strength using this strength slider. 1 is the default value. 0 means that the bumpiness effect is off. If you set the strength quite high like 10 or 100, you can get even stronger bump effects. You can also put a negative value. Notice that negative values reverse the bump effect. Now the tile blocks are going down while the gaps are going up. I think we can see the effect better if we unplug the color texture and also the roughness texture. Again, you can see how the effect is reversed due to negative strength value. Okay, so that is basically how you can use normal map. Let's set this back to 1 for now. There are at least 3 limitations that you should know regarding the normal map. The first is that normal map can only produce fake bump effects, meaning that it cannot alter the geometry as the displacement effect does. If we see the object from the side, we will just see a flat surface. The next limitation, which I think is the biggest downside, is that you cannot rotate normal maps via the mapping node. Why is that? This is because normal maps are specifically built for certain X, Y, and Z orientations, so rotating it away from its original orientation will break the effect. Just to prove this, let's rotate the texture 180 degrees. As you can see, now the bump effect is reversed. The tiles are going down while the gaps are going up. It is like having a negative strength value. Please note that this is not a problem specific to Blender, as all 3D software have this problem also. But still, I really hope that in the future, Blender developers find ways to automatically fix normal maps when the mapping node is rotated. For now, the workaround to this issue is to avoid rotating the texture via the mapping node and use the UV editor instead. I know we haven't discussed UV mapping, but just to give you an insight into how it works. If you rotate the faces in the UV editor, and then check the rendering result again, as you can see, the shading or the bump effect is perfectly fine, although we have the texture rotated. Alternatively, if you really need to use the rotation slider, such as for creating animation, then you can always use the displacement map instead of normal map. Okay? One last important thing that I need to mention before I end this video is that you should not use normal map together with displacement map. Why? You see, the most common method to create normal maps is through a process called baking. Essentially, we first create a high-resolution version of the model, and then project the surface information into a low-resolution model. In other words, normal maps are built for specific 3D models. And because most available textures on the internet are general textures that are built for flat surfaces, when we displace the surface and then apply a normal map to it, the result can be expected. So again, although technically you can use both together, it is better to choose just one, whether you use the displacement map or the normal map. In this video,